user group. My name is Kevin Chomba. I'm a lead at Kenya Data Platform. I'm also a software engineer at Griffin's Global Tech under Microsoft MVB, web development and Cosmos DB. So today we have a quite exciting event with us. So we have been talking about SQL for the previous calls which we had. Today we're going to kind of deviate from that and deal with a non-SQL database, which for this case is DocumentDB. So just a small kind of introduction to DocumentDB. So if you just search DocumentDB, you'll be taken to this homepage that is documentdb.io. And this is a database which is fully compatible with MongoDB. So the other thing is that this is a database that is built with a Postgres SQL engine. So on top of Postgres, they have created an SQL database on top of that. So that means it supports with things like BSON, which is like a JSON file with superpowers, natively. Okay, so most of the things we'll be doing will be things that you have done with MongoDB, but it is going an extra mile, and this database supports things that are more than MongoDB. For example, it has things like native rich indexing files, indexing engine, and also we have like native support for vector search and hybrid search. So with this, we can do RAG applications with ease without using libraries and packages. That's something I'm quite excited, which we are going to cover in the next course. So where did this database come from? I know that's the big question. So there is something known as the TSC, and there are members there. So they are kind of open source group of organizations which came together. For example, Microsoft, AWS, and these other three companies, they came up together to create this database. So when you go to Azure, you'll find this database. When you go to AWS, you'll find this database being supported natively. But also, you can use a Docker container to run this database locally, which is a cool thing. So this database is so cool that even they have support for Kubernetes. So they have Kubernetes support baked into the database from scratch, which is a cool thing to see. So if you're doing some AI stuff, you're good to go. If you're just doing CRUD applications, you're good to go. That's something I found interesting, and we shall be digging deep into this. So for example, when you go to Azure and search DocumentDB, like DocumentDB, you're not going to find any database. That is because DocumentDB is an API in Azure Cosmos DB. So if you go to Azure Cosmos DB and you want to create a database, you'll find that we have recommended APIs and other APIs. These are just some APIs for Cosmos DB, but the recommended ones. With this, you see we have Azure DocumentDB. So this is the version of DocumentDB that is offered as a service in Azure. So whether you're using these or you're using it in AWS or you're just running it locally using your Docker containers, it's the same database. All the functionalities are there from scratch, which is a cool thing to find out. So I wanted to give you like a background check of DocumentDB, and as we move on, you shall see things like by the way, its documentation is quite easy. You can just come to docs, and if you're getting started, click on get started. You'll see how to bootstrap a Docker container with this. and it's quite easy. You can just run it locally on that. The other cool thing is that in the docs, you'll find that you have these API references. So API references will kind of help you to use this MongoDB query language, which is MQL. The same way we have SQL. Now here we have MQL. So MQL is a bunch of chaining objects, like not objects, but method chaining, kind of language, which will help you to do anything. So for example, you want to delete something. So you do like db dot collection dot delete, and then you pass like the ID. Okay. So we'll have like filter option. So you can filter something like, hey, delete this collection where ID is. That's a filter. Okay. So you shall see a lot of similarities, almost 99.9999 similarities with MongoDB. But as I said, we can do more than the things that MongoDB is doing. By the way, even in Azure, you still have an option to spin up. By the way, there is none. There was Azure Cosmos DB for Mongo, but now I think it's fully replaced by Azure Cosmos DB for DocumentDB. Yeah, yeah, that's good. So with this now, I think I've reintroduced what is DocumentDB. I think we can dig deep into this. Yeah, they also have an extension. So there's this DocumentDB extension. I'll show you how to search it on VS-code. It's under development. So for those serious engineers, I think you can contribute to this and add it on your resume. But it is something we shall touch a lot. Yep. Other than that, I think other things are okay. I think we can jump into it. So today we still have our Nest application. The only thing that is changing is our database. Yeah, which is now DocumentDB. So we shall do like the NoSQL fundamentals. We do some CRUD, we do some aggregations here and there, and then we shall talk about a little bit about NestJS architecture, how you're going to groove these up, like the MQL with our Nest applications to do some few things. We shall use a simplest application, the second simplest. The first one is to do now, we'll be using blog application. So we shall have post and comments. Yeah. And then we shall use the MongoDB driver, which is native. We are not going to use the Mongoose. I don't know why people use Mongoose. It's just abstracting something for no reason, according to me. So we are going to use MongoDB driver direct. So we are going to go barebone without wrapping libraries, unnecessary libraries on top of that. But I'm not saying Mongoose is bad. You can go and use it if you like. For me, I don't see any reason to use Mongoose with DocumentDB. So a DocumentDB is a non-SQL database. So non-SQL database or non-SQL server kind of have this flexible schema which you can model or create it the way you want. So we shall see the architecture of how these things laid out from the server to the collection to the documents, and how these you can compare it with a SQL database. Again, DocumentDB is built on top of Postgres, and it is fully compatible with MongoDB, and it has native AI capabilities baked in from scratch. When I say AI capabilities, I mean you can use it as a vector database, yeah, to build your APIs. So these kind of the NoSQL 1.1. So if you have ever done any SQL database, think of row being a row in a table, being a document in a collection. So after that, there is the container. So the container is like a table in SQL. We have collections in DocumentDB. In SQL, we have like a fixed schema. In DocumentDB, we have flexible schemas. In SQL, we have foreign keys and joins to create relationships. In DocumentDB, we have two ways of creating relationships between two related documents using something like refs and appended documents. So where you have like big documents of posts, and then inside it, you have comments as part of that object. So that is an embedded document. But for the post ID ref, which is the best way to use it, you'll find that you have like the posts object, and then you have the comments object, and then there's the post ID inside the comments object, which is when you're querying the data, you're going to create a reference just the same way we use a foreign key in a SQL database. So here we have auto incrementing IDs for SQL. Here we have just an object ID, which is a 12-bit BSON, which is auto-generated. Okay, so in SQL, we use SQL as our language. Here we're going to use MongoDB Query Language. So these are some of the things I was trying to explain, like you have your post document and comments. So yeah. So we shall do the CRUD and go beyond that. We shall also do some filtering and pagination here and there. So these are this is like the data you get on my left-hand side, and not the data, sorry. These are the filters you get on the left-hand side. Like when you're fetching data, like, hey, give me 20 users who are greater than 20 years. So that greater than or equal to GT, it's an operator. Okay. We have LT, we have other things like tags, we also have logical operators like OR, and so we have a lot of things. Yeah. So this is the code for inserting, deleting, and then we have like update operators where we use set. Mostly we use set, but you can also use push, pull, CRUD, increment, sorry, and unset, which is the opposite of set. Yeah. So I'm not going to explain everything about this because we shall do this in the code. We also have aggregation. So aggregation, we use this to do operations like count. So you can fetch like, hey, fetch 20 users whose age is greater than 10 years. And for you to know it's 20 users, you can group these users and do something like count. And then you can reformat the return type of that query by using operators like project. And also you can sort like the oldest person who is above 20 years or 10 years. So you can do sorting, you can project, you can group, you can do all those operations using this. Okay, so this will be what you do in Nest. So you have your validators, that is our Zod body and params to kind of filter anything which is coming from the user. You have your controller, which is going to hit a service. Service is going to talk to a MongoDB driver. MongoDB driver will give us an instance of the connection, and then that connection, we're going to use it to query data. So, and this is going to be initialized using our own module init, which is a method that is executed in a class, in a node class, especially for NestJS to be specific. to be executed before other methods. Yeah. So prerequisites, we just need Docker, npm, and mod. Let's jump to the README file, which I think we have more explanation of what we are doing today. Okay. Just a moment. Here we go. So, jump one fast to the README. Good. Yep. So I needed to use this to discuss some few things because there are some things I just went through fast. I wanted us to dig deep a little bit and understand some few things. So let me just jump on to, I think most of these things I have explained, but I wanted to use this diagram, for example. So this kind of shows you the comparison between SQL and non-SQL databases. So we have our server at the top level or at the bottom, and then you have your database. So this can be a database name like a blog. And then you have your collection, which is posts, which is now like a table. And then you have your documents in this collection, which can be like a row in a table, right? And then you can have different collections, which can be like different tables, okay? And then you can see here we have like the post ID, which is part of the post, but they are being stored in different collections, which in SQL, this is like a foreign key, okay? So something else I wanted us to discuss is how do we do relationships? So comparing this into an SQL, we all know you have table A, table B. Table A has all records. Table B has the primary key of these records here. For example, like post ID is a primary key in post table, but here it is a foreign key. So by you doing a query pointing to the post ID, it will help you to connect these tables and create relationships, and then you can do joins to query data. Comparing this to an SQL database, we have like two ways of doing things. So the first way is having the post object, and then inside it, you have a key known as comments, and then you can have an array of comments. So this is the first way. So for this, you don't need any joins. But the challenge with this is that DocumentDB, for example, DocumentDB and MongoDB, they have a limit of a document. So for example, think of this as a document. So if it is above, I think 16 MBs, it's no longer going to be saved. Something like that. So that's one of the limitations you find. So it is not ideal because if you have like a million comments, that can make this file or this document to be above that. Okay. So which is the better option? So there's this referencing option. So where you have your post collection, you have your comments collection, but now we have our post ID, which is acting as a ref, like what we have like a foreign key. So what happens with this is that we have smaller documents and they can be changed independently without having to affect the other one. Remember here we had to, if you change something here and change something here, we are still changing the same collection. Sorry, the same document. So it's kind of tampering with comments and comment and post at the same time. So even when we are doing aggregation here, it becomes easy because now these two things are, we're just refreshing them. We are not using one and then looking into it. So like the way we do here, you're fetching or all the posts, and then inside the post we are doing a lookup. It's like a search within a document. So is a simple example. Like this is how we query data into two tables that are related in SQL. So you have your select these is as these from this table, left join these on where ID is equals to this. So that is kind of how we connect things. So in NoSQL, we have like two options. So the first option is basically, as I said, option A, where you have embedded, where you have everything stacked into one object. We shall do like post find where ID is equals to this, and then we fetch everything at a go. Okay. So now in our next option, which is now NoSQL option with reference, now we have two queries. The first one um, will fetch all the posts, and the second one will fetch the IDs. And you can also, this is an option, you can also use um, a second option in option B. Think of this as option A. Option B, we have two ways you can query both of them, like the posts and the comments. And also you can do a single query with lookup. So this is equivalent to how we do things in SQL where you have a join. So this looks like my thing. Prefer going with this than executing two queries. So as I said, why is this important? It's by the way, it's more advanced. It's not something I should point out in the first place, but I find that most of the people who are new to document-based databases, they kind of make these mistakes of knowing how to relate different documents and how to fetch them, those type of optimizations, which can make you look bad. But we are going to try and solve that. I hope you're all together. Am I audible? Are we doing everything okay? Let me see some thumbs up. Yeah, okay. See Simon saying everything is okay, and Sarah. Yeah, so cool. So that's something I thought I should emphasize. So when I push this code, you'll find this quickly with all the instructions, and everything is well commented. Cool. So as we said, we have a collection, we have documents, we have everything. So I think that's it for that. Uh, uh, this is how the project is supposed to look like. See, we have our app.module config, we have our common, and we have this Zod decorator and buried data, which we have been using for a while. Before the call starts, I was just talking to Simon. I think Simon was there and Bernard on how like NestJS version 12 will help us get rid of these two files with a line of code, which is so cool. I think I'll create a call for that to be a short call, and you shall see how cool it is that they have embraced Zod as I expected. They're using Zod for almost everything, and you shall see how you can create good JavaScript or TypeScript APIs with less lines of code, and the app is way fast. They have also introduced V-test for testing, so just is out of there. So we just have super test and vit test for that. I think I'm going to create a call for that, and it will be cool on how you can migrate your existing application to the new thing and play with it as it becomes stable in some few weeks or months. Cool. Other than that, we have our modules folder with all the posts and then our comments. Yep. These are our endpoints. This is a deep dive dive on different ways of doing aggregation and updating and all those. I've documented everything from scratch. So if you don't touch anything today, you can come to this with me and understand even how we are doing validation at the control layer. Even though this will be absolute very soon. I'm just giving you guys as a warning. It's funny how the JavaScript ecosystem kind of changes very fast. So if you take a break for 1 year from JavaScript, you might come back and wonder what people are using. you're, you're there trying to write a JavaScript API and people are using TypeScript before you learn TypeScript. People are using, they are no longer using class validators, they are no longer using these and that. Yeah. It's always cool to keep up with everything. So the extension I was talking about, is document. Come on, can't type. So we have this DocumentDB for VS-code. So we are going to use this extension. I've pinned it some. It should be. This is Postgres, Mongo, Redis, Cloudy. It's not appearing. Let me just try it. Okay. Let me just put it on top. There. Your larger. Cool. So here is our documenting. So I'm just going to delete the connection so that we can do everything from scratch. Yeah. So I already deleted this. Cool. Everything is good. So as I said, let me show you where you can get. So we have these docs home. Yep, we have these command which you can use to kind of extract some few things and create your Docker Compose file. Okay. If you have some issues, I think we have covered this. So in the Docker Compose file, this is where we are starting everything, right? So this is just a code to build our API, which I'm going to discuss in the previous course. We did this. So minimize that. Then we have our DocumentDB. This is the URL where we're going to get it. And then the second command is username. You give it admin. You can give it whatever you want. And then -- password. You give it whatever you want as your password. And our port is 10.26.0. That is the port we are going to use. This is just a small command to test using Mongo. That is a CLI version of CLI tool for MongoDB to just test whether this is okay. It's going to ping, and then everything is just the same. Cool. Other than that, I think we can go ahead and create this container. So let me see whether I have my Docker. Okay, I have my Docker already open. So I have already my Docker open. As you can see, nothing is running and we need to spin up something. So it's easy if you have your Docker Compose and you don't need to run the scripts which we have been using in the past. It's quite simple. You just need to do Docker Compose app and then the name of the service you want to run. Okay, for our case, we have two services, that is app and DocumentDB. So I'm just going to use DocumentDB like that. Okay. like that. So there are two ways, because I don't want to see the logs and those kind of things. I'm just going to do the detached mode. So let's see. So it's going to create the network and the container, and everything is up and running. Cool. So if we come here, we shall see, for getting started with this, we have our database, document database, which is creating some few things, testing this and that. There's this error that is not for us. It's something you should be worried about. Something it's testing with gateways, and we are not going to use that. So as you can see, the database is up and running, and the port is okay. So let's connect this. So in the .env example, you shall see an example of how the URL starts. It starts with MongoDB username, password, domain that is localhost 10 26.102.60, and then there are these TLS for testing that it's true. For you have your own certificates for making sure the connection is correct and good. So for case, I have that already here in the .env file, and then we have the database name is blog. So I'm just going to copy these. You can copy it up to here, but I'm just going to use everything like that and connect it to this. So I'm going to create a connection and use connection string. So if you have your database in Azure or AWS, you can use a service discovery. So for us, we're going to use a connection string for our localhost. Paste everything there. Press enter. It will ask you, do you want to use username and password? Yes. The username is admin, as you can see. The password, I'm not sure what they have, but let me just copy this. Paste it as password, and then press enter. And then now we have a connection. So this is the server. So inside the server, you can see your database name. Okay. And by default, it will create sample DB. So this is not our database. And then inside sample DB, you shall see some few documents for products, users, and everything. So once we run our first queries in our database, that's when something will be created there for us, like our database. So let's speak about code, and then we shall go back there. So simply, this is our normal NestJS application with main.ts, where our whole application is starting in. We have config service helping us to fetch the .env files and ports and everything, which we have already covered that in the past. But inside config, this is where we have our schema, kind of creating everything into an object which you can call. And then we have our app.module, where we have like config.module, which is responsible for finding these .env files based on the environment. We're also adding database module so that it can be used globally, post and comment module. Speaking about database module, this is where we connect to our database. So jumping inside modules, we have our database. And then inside database, we have database module, which is basically nothing but just importing our service. And then inside the service now, we have some few things. We have a client which we are going to use to create an instance of our connection. So we are typing it as Mongo client, and we are telling TypeScript, hey, this guy will always be here. So after creating this property, we can use it to our methods. So in our constructor, we are just bringing in config. So config is a type we created. Using this type, we can connect to different things. For example, URL, we are just getting it from config.get, and then we have our database connection string. So using this URL, we can build a client. So we are just calling the client property using the this keyword, and then create a new Mongo client, which will be an instance of our database connection by passing the connection string. So now that we have this, we are just returning that after we connect to it. We are returning an object with a connection, if that makes sense. We are using on module init, which basically in TypeScript, especially in Nest, because it's a Nest package under Nest common. It's when we name our method as on module init, every time this database.module, which we call the service later, is called in a file, it will initialize this piece of code first before any other piece of code. Yep. So this is cool because now we shall have like a singleton type of thing going on, and it will always be ready before we use it. Okay, and also we can delete by using the module destroy. So when there's no connection or we have stopped our API, it should close this connection, which is a cool little thing that you can do more than this. You can do like get collections, so you can see all the collections in the database by using this generic method that was being created here. So yeah. Other than that, now we have our database connection. After this, we can use it. So for example, in posts, okay, basically we usually have details which are supposed to help us validate or filter the data which is coming from the user. So if the user's post need to have title, content, folder, and tag, user detail to validate that. In conjunction with Zod, Zod is a validating schema. By using a decorator and a pipe, we are able to use this DTO inside our controller. And that is, for example, let's say we are creating a post. We are able to call the Zod decorator using the @Zod body, which we are importing, as you can see, from decorators. This Zod body is going to accept a schema for a case. This will be, you can use the DTO, no, sorry, you can use a schema which we created inside this schema files. So inside here, okay. So you pass the create post schema. Sorry, I think I confused people there. Create post schema is still inside the DTOs, sorry. So when you go to create post, you shall see we are exporting a type node create post DTO. And we also have create post schema. Okay, so we have a schema and a DTO, which is basically a type of our schema. So in our controller and create, we are passing the schema and also now the value which is going to carry our data, which we are calling it DTO, you can call it posts, whatever. We are typing it with the type which we have inferred from our schema. Kind of cool. So you get type safe all through it. Okay, so speaking about methods, we're going to call, as you can see in our control, we're just calling services, methods in the service. So in the constructor, we are just calling our service. And inside the service, which is our post service, we are just calling different methods like fetch all, find one, create, update, and publish, and delete. So for now, it's remove. So those things are available in our post service. So inside here, you can see we have find all, find one, create, update. So, but what are these? So inside create method, we are bringing in our type again to type the data which is coming from the controller. And then we're creating a new date, and then using this Mongo Query Language set, for example, insert one. So where are we getting posts? So going back on top, we have the same pattern. We have our posts, which we are telling TypeScript it will be there using this shebang thing there. And then we are calling the collection from Mongo. We are using it as a generic class, and then we are passing the type, which is our post coming from schema. So this post object will be aware of the type it needs, which should be enforced by the collection from Mongo Python. So we have posts. Now on module init, we also have module init here. We're just saying that, hey, this post, which is this, is going to be is equals to this DB, which we are injecting it through our constructor here, which is the connection we got from the database service, if you remember, which we returned the connection. We are going to get it and call it DB here by passing it here. So we have DB, and then we can be able to get the collections. So get collection is a method in MQL, which you can use to get all the collections. For this instance, we just need the post collection, and then this is a type, by the way, but we just need the post collection. So for all the CRUD functionality in this file, we are going to use the post collection. So if you have different collections, you just need to create something similar to this. Let's say this is post. Now we shall have like comments. We'll be able to type comments and then call it from comments, and then you shall have your own comment property. So for example, let's say we are finding one. Okay, so this is easy. We just need to post.find one, and then we pass the ID. So this is the filter part under this method, that is find one. It has filter and params. Okay, so filter is this. While using the new, so the ID is in DocumentDB and MongoDB. They specifically forces us to use the object ID. So you have to call this class, that is object ID class. But the way we are calling it, we're using new keywords. So we're creating an instance of that class in simple terms, an object. And then we wrap our ID, which is a string, into that. So this makes sure that the ID we are passing, it's DocumentDB compatible. Okay. So it's kind of a validator at the same time. Okay. So but this is something you can do about it, because it's something you shall do almost in all places you need an ID. It's something you can automate using an external file, which is called every time. Maybe a decorator, just small function to do that. Anyway, if there's no post throw an exception, return a post if it exists. So so if you need posts without ID, you just use this without ID coming from MongoDB to return your post without an ID, which looks funny in MongoDB. It will, how can I explain this? A normal ID, as we shall see when we are doing with DocumentDB, it is simply underscore ID as a key, and then open a new object, and then it will have another key there, and then the value of the ID. So this will kind of filter that and return it with a proper ID as you expect, like underscore ID, and then the ID you have here. So let's do CRUD. So now we have everything ready. We have our Docker container. The only thing we need is to do npm start dev to start our API. And then as you can see now, we still don't have our database with us. So we shall have that in a second. So if you check in our app, we have this app.http. This is where you document like everything that you need to do in request for something like Postman. So let's try to fetch our data and see. So sending like we have this syntax. I think we have discussed this before. It's like a variable. This is how you put a variable using these syntax, think Angular syntax, where you create your base using @base, and then you put that and you reuse that. So let me send this. You shall see we have empty, so there is no host. But we still reload this. You shall see we don't have anything. Okay, then we are fetched. So that's not an error. That will appear when we create something. So let's create a post. I will send this. So we have created a post. If I reload this now, as you can see now, we have our documents, our collection of us blog. Sorry, our not collection, but our database name known as blog. And then inside the database name, we have our collection, which is posts. So inside the post, we have documents. Okay? We have documents. So this is it. So if I click on documents, if I double click on this, and then maybe zoom out, zoom out a little bit, we should see just one document. By running find this, we shall see one document, the one we have inserted. Okay. So we shall be using these to query things. We also have a good Query CRUD with us. This one is cool because it's developer oriented. So let's say you want to do something else, like know the collections we have. So if you do db dot, you shall get this inheritance, which is cool. So if I get collection names, for example, this returns an array of collection names in the current database. So doing that and then calling that, and then you get this run command. If I run this, as you can see, we shall get one collection, which is post. So you can do everything in this file, which is something amazing. We shall come back to that later. That's it. So, okay. So now we have our thing. We can do more things like CRUD. So we have insert one, insert many, those type of operations. I'm not going to do that. Make sure you go and run these things. Everything is there. So what I want to concentrate, I exported this file, this into a JSON file. So this is a file you can use to do a lot of things like the Mongo Query Language. Okay. So for you to do this, you can't run them just by opening it. Like you can't do like open this file. You see it is not connected. So what I like doing, let me just split this into the right-hand side and go to our DocumentDB and click on one document or all the documents. And then inside this file, go to playground. Okay, so you shall have this file which is connected. Okay, now that you have this connected, you can do the things as I was saying. So for example, if you want to know whether you're connected, you can just copy this and maybe use it here like this and run. So we should get, okay, so that's a ping. You are running a command to ping to your database and it will return an okay, it's a ping back. Okay. So you can list all the databases by running a command like this. And it will be, but as I said, you have that inheritance, which will help you do that. So running these, you shall see we have SampleDB and BlogDB, which you can easily confirm. You can easily confirm here in the Mongo. Yep. You can see we have log and sample as our two databases. Cool. You can go ahead to do even connections and see how many connections we have. So if you have different commands, you just need to like create assembly comment to help you separate the commands. And if you run this, you have an error somewhere. Let's see, we are missing D. Run this, you should be able to see we have two admins. Yeah. So we have all these get users, get stats. So this is also a good language, but then you can use even in your database. For example, in your database service, you can create here a function to execute this. As you saw, we are doing something like config.get. You can just use this to do a stack. So for example, what Copilot is saying, something like this. So everywhere you call this function, it should always return the stats of your database, the same way we are getting it under here. So it's quite powerful. So if I run this, I should be able to see my database name. It has one collection. It has all these things. The most important thing is the size, okay? And the size of your database. It has these bytes. So if you want to display this in your front-end application, you just need to write this inside the function and execute that. How cool is that? So cool. These are a lot of things you can do. So let's do some of them. So if you want to create, for example, but even version, if you're interested in knowing after deploying your database in Azure, if you want to know which version it is running, it's just this DB version. Shall get it 7. So I want us to create these collections. So it's simple. You just do db.collection. So once you write create collection, once you just name like create, you shall get these iterations. So create collection like that, and then so if you're not aware of how it does, move on it. It will tell you that it requires just one parameter. So that is a collection name. Okay, the name of the collection. So that's how you learn these APIs inside this language. So by just copying these like this and highlighting the 3 of them and in run, I should be able to execute db.collection post trace. Okay. So if I want to confirm, I can just do get the names. So if I do get names like this, I should be able to get all the collections which I've created. So if even I reload this, sorry, we won't see anything because we have not inserted anything, but let's see. Oh, okay, sorry, we'll see them. I thought we won't see anything. I think the first thing when you insert anything to the database, it will create database and a collection. So other subsequent creation of collections, they will just appear automatic. That's something I never knew. Anyway, even if it's empty. So these are like tables. So we have 1, 2, 3 of them. Cool. By just doing this, you can get that. So you can also delete by just doing collection, the collection name and drop. Anyway, let's insert one data. So this is equivalent to what we were doing in our service, like inserting something. So for example, under post in service, we had this insert method, this one create method. It was just doing post.insert one. So basically now we are dealing with this part of these queries. Posts is what we're having as DB. Okay. Yeah. So okay. So let me insert things. So hovering on this, run this. As I say, this is what I was looking for. So you get, after you insert something, there's inserted ID and then this funny ID and then the value which you want. Okay. You can insert many by passing an array of objects. So for example, this like that, run this, we have inserted 2 of them. Okay. If you want to get the values, we shall do those queries. But there is this simple one here. For example, this one is for deleting the collections of the documents. We shall do that later. But let's say we want to get these corrections. It's just the correction name, find to array. If you don't do to array, you can just leave it to return that JSON by default. So these you shall have an array of objects with this funny way of putting an ID and then other things. So these are a JSON, an array of JSON objects. Okay. By now, I think we have a clear understanding. Something I found cool is with regular expressions. We all know that regular expressions in computer science are a little bit tough to even understand how to use them properly. But in these queries, they are so easy. For example, so let's say you want to search something that is ending with DB. So let me show you how easy it is to do that. So if you know a little bit of regular query, regular expressions, like my friend today is not in, my guitar guy. It's not in today. Anapenda sana regular expressions. So, so as you can see, we just call the table collection. Then after we call the collection, we use the find method. So the find method is easy. We are finding, let's say, a property. As you can see, we have topics, mentions, and dates. We want to find threads where the topic ends with DB. How do you do something with that? It's easy, just add this forward slash, and then you just write DB and then end with a $sign. So this is a regular expression for any topic that is ending with DB. So if I run this, we should be able to see this topic is ending with DocumentDB, of course, DB at the end, NoSQL DB, so that I can make this easier so that you can see it's not just returning the same thing. Let me add O. So O will help us only return the ones with MongoDB because we have the O and then DB. Running this, now you see we just return one. Yeah, that's so good. Something else, if you need to return something that has an M inside a word, so something like MongoDB, I don't know which name I can use. MongoDB has an M inside that word. Anyway, you just use this regular expression for this, just this. So let's see, let's say we want something with this, like that. Run this query, we get empty. Okay. Is this ending or starting? Oh, starting, sorry. Starting there is 0. So because they are starting with N and M. So if I do the N or M, this will give me, yeah. So for the metro one, we just use this slashes, okay, so without this. Okay, so let's say we search with, in the metro, we need something like S. Run this should give me just 1 because we have just NoSQL, we have S and the metro inside the text. Yes. Let us prior to S and post S. Cool. I think there is a lot of things here you can do. You can do paginations. I have created an extended file, which you can just copy paste the commands and plan them. As you move on, you can do greater than. These are comparison operators. Greater than or equal to, less than or equal to, not equal to, then in or inclusive. So I think I've spoken a lot, but yep. This is the fundamentals of the DocumentDB. With this, I know you guys can create a DocumentDB type of API with all the things in it. You have baked in pagination. Yeah. Any question? I think I've covered DocumentDB. So this file, well, will help you know those things. So by the all these things, you only need them in your service file. So you see your methods where you're doing like post stuff. Yeah. And just in case you want a detailed documentation, so if you go to docs and the API references, you shall get them here. So let's say you want to query or write something. So if you want to know, let's say something to do insert. So you click insert and you shall see like db.collection name and then insert. Okay, and then you pass the data. So you shall have these detailed examples, and it's a good documentation on how you insert one, insert many, and all advanced queries. So once you're done with CRUD, you can do things like aggregation. So you can do like count. How do you do count? These are you do count. And at the bottom, you have some queries. What? Okay. You can also do operators. Yeah. Any question? We have done our live demo. Any question on this? So, where do you find the code? As usual, it's in our user group page, just in case you're watching just this video in a recording. So if you go to our user group page in the comment section, which I'm just going to do right now, wait any question. So you can unmute your microphone and ask any question just in case you have. So our GitHub page usually has a lot of repos and not repos but folders. So just in case you don't know where to find this, so you know github.com Kenya Data Platform User Group separated with a dash. Go to repos. Node.js backend development. This is a series we are currently working on. So going inside it, you shall see these are the previous calls we have. So if, in our meetup page, you can always see these things. So if you clone these and always fetch, you shall always get for everything. But if you want a specific link to a specific project, that's why I'm copying something like this. So this will take you to this code base, which we have covered today, with all the explanation about what we did in the README section. So that is what I usually put here in this. Okay. That's after this call, make sure the recording is also on the comment section. So this, so if you come here, you can always get that link. So this recording, I'm going to upload it on YouTube. So you shall see the recording URL in this comment section. For example, if you go to our previous course, this will be the next week call. So for previous call, we'll click to the user group, go to events, can sort these with past. So if you go to past, you shall see all these things we have been covering. So let's say you want to watch what we did here last time. Click on this. You should be able to see two links, the GitHub one and the YouTube one. Okay, this should take you straight to the code base of the recording. Any question? None. I think that's all. There's no question we can end our call here. Hopefully we record.